Hello, today we're going to look at the trapezoidal rule, which is a way of using our trapezoidal area formula and combining a bunch of trapezoids together in order to get the approximate area underneath a curve or between two curves. Now this can come up in two different forms. This can come up with a picture or it can come up with a function. Those are the two styles that have tended to appear. And again, this just gives us the approximate area in between these curves. So how much area is there approximately between these curves or between the x-axis and this curve here? That's what our function, or our formula, I should say, is going to give us. A note that is important to make from an exams perspective is that integration, something that we are going to do in the future in calculus, gives us the exact area underneath a curve. So right now we're learning the trapezoidal rule, which gives us the approximate area underneath a curve or between curves, and integration in the long run will give us the exact area underneath the curve. And an exam question could very easily contrast and compare those two approaches and the error perhaps between the two approaches. A reminder, the trapezoidal area formula is in your log tables, and I have deliberately switched it over here so it looks more like what it will in the diagram. We have our side length A and our parallel side B and our height in between, and the area of that individual trapezoid would be A plus B over 2 multiplied by H. This is in our log tables. The formula we're going to use today is on page 12 in our log tables, and it is called the trapezoidal rule in the log tables, and it's given here, and a picture is given to help interpret what's going on. So we have y is the first height. That would be the A for the first trapezoid. So we would approximate this as a trapezoid. We draw this in as a trapezoid, and we draw this in as a trapezoid. So going between here and here, and draw them all in as trapezoids, and we get the area of each one of those individually and add them all up. But we don't actually do that. We rearrange the algebra of the formula in order to give us one big equation that we're going to sub into. So here we've got our formula. We have the h divided by 2 sitting out here from all of our trapezoids. They all have the same height, which is effectively the distance between each one of our measurements here. So our y1 is our A, our y2 would be our B for our first trapezoid, and then for our second trapezoid, y2 would be our A, and y3 would be our B. And you can see that y2 has shown up twice already in our trapezoid, so all of them get counted twice except for the first length here and the last length here. They don't end up showing up twice in our list, so they only appear as the first and the last. So a bit of reminder on notation for a series, or sequence I should say. This is y1, so this is the first length, and yn would be the last length, and yn minus 1 would be the second to last length. So whatever length would be around about here would be yn minus 1. It'd be the second to last length, and that would go in here. Now let's put this formula into practice. So I have a little diagram here, and I have something we could say that it's a sketch of around a lake, and how are we going to estimate the surface area of the lake. Well, if we wanted to get the approximate value of it, we could use our trapezoidal rule, and we've already got measurements across the lake here. Our first measurement here, our lake is a bit funny, it goes straight down from this point, so it has a length of 5, so that would be our y1, that's our first length. Our second length, y2, would be 15. Our third length would be 10. Our fourth length would be 12. And what would our fifth length, our yn length, be? Well, it would be 0, because our lake comes down to a point here. There's no length that we would measure. It ends at a point, and therefore it has no length. It's a length of 0. So yn in this case could be 0. This is a fairly common thing that they can throw at you in the exam, either the beginning or the end, usually, of our shape could come to a point like this, and then it would have 0 length. So let's write in our different lengths, or let's write in our formula first and then write in our different lengths. So our area that we're looking for is approximately equal to, so we write down our formula and then write all of the bits we can sub into our formula, because they could also tell us the area and get us to find the missing length. So it's important we're reinforcing good structure all of the time. yn plus 2 on y2 plus y3 all the way down to yn minus 1. And that's our formula. So let's write down all of our different pieces. The gap between all of these measurements is 10. We always are going to have the same gaps in between each of these. So we have h is going to be 10. y1 is our first length, which we're given as 5. y2 is 15. y3 is 10. y4 is 12. And y5 is going to be 0. So again, be careful of this. There's no length there, but that is still an interval. So we need to have our final length as 0. Now a little bit of labeling work. This is yn minus 1 because it's the second to last number, and this is yn. So that is yn minus 1. That is yn. The last term is yn. The second to last term would be yn minus 1. So those are all of our different pieces. We're looking for a. So let's sub in. Area is approximately equal to, that's what our wavy equal sign means, 10 all over 2 on y1 is 5 plus yn is 0 plus 2 on y2 15 plus y3 plus y4 up. So we've gone up to yn minus 1. This is where we stop. And we put that into our calculator. And we get, well, let's do it out as 2 steps. 5 on 5 plus 74. And it ends up being equal to 395. Now this is obviously an area, so we can call that units squared. So that is one way that the question can be given to us. Another way is that they could have given us a function. So find the approximate area under y is equal to 2 to the power of x from x is 0 up to x is 3. Now I've drawn the diagram in for you already. You may be asked to draw it as well, but we know how to draw exponential graphs. So let's get our formula again. H2 y1 plus yn plus 2 on y2 plus y3 on up to yn minus 1. And let's get all of our terms in. Well, this time we're going up in ones. We're going 0 to 1, 1 to 2, 2 to 3. So h is going to be 1. And that would be a standard number for doing it, unless they give you that you are going up to like 300 or something, and then you might go up in hundreds or tens or 50s or something like that. Your interval will usually be 1 for this style of question. And again, what we're doing is effectively drawing in straight lines between our points here, so that we create, in this case, 3 different trapezoids. Now let's get y1. y1 is going to be, our height here is going to be 1. y2, so our first height is y1. Be careful of that, particularly with a function, because this will be x is 0, so don't get confused between your x numbers and your term numbers. So we have y1 is 1, y2 is our second height, is going to be 2, y3 I should say, is going to be 4, and y4 is going to be 8. So now we have all of our terms. Let's sub into our formula. To 1 over 2 on 1 plus 8 plus 2 on our two terms, so 2 plus 4. Again, this is our yn minus 1, our second to last term, and our yn, our last term. We put that into our calculator, and we get 21 all over 2 equal to 10.5, and again, units squared. And that's what we need for our trapezoidal rule. Again, they could have given us the area and expected us to find one of our missing terms, but we'd just be subbing into this equation and rearranging to get our missing length, which is no harm to us. We know how to do that kind of algebra. So that's what we need for our trapezoidal.